So today we are going to see uh, Unit 1 of Year TS, and today's topic for discussion is embedded system design process and its top-down design and bottom-up design. Now, majorly the design process has been divided into four major tasks. One is called as partitioning, another is called as allocation, third is scheduling, then mapping. So, on dividing into four major tasks, we'll start the design flow with the design specification, functionality, and hardware software partitioning and same integration. Finally, we'll verify and test. So, in general, when we consider what is called as partitioning is, we are going to in we are going to split the major function into smaller interacting pieces, right? So what is going to happen, this major function when split into smaller interacting pieces, these will be executed step by step. So on partitioning we may able to speed up the process. Then allocating. After partitioning, the next process allocation, we have to allocate the partitioned pieces to the allocated microprocessor, which may be multiprocessor system, or we may have a uniprocessor system. Okay. Third one is called as scheduling, and after allocating these microbuses, it has to be scheduled because we have to notice when at what time the functions has to be executed. And finally mapping, we have to describe the functions and you have to implement on a particular set of components. So these are about embedded system design process. Next is the design flow model. So we have two different models here. One is called as top down design, another is called as bottom up design. So as I discussed earlier, it consists of requirement specification, architecture, components, and system integration. So the major difference between these two things are nothing but when a system is designed starting from requirement and finally end up with system integration, we call it as top-down design. So the same thing, when it is done in as a reverse engineering, we call it as bottom-up design. Similarly, it starts with system integration, component, architecture, specification, and requirements. So when we go with what is called as so we have seen five different models in the previous diagram. So here we are going to see what is called as requirement. So requirement is nothing but what a customer needs, that is. So it is a generic word. So that is called as requirement. And specification is nothing but in the technical aspects of the system, or we may even name it as system function or characteristics. Then architecture, so we need to draw or design our architecture depends upon the requirement and specification. Finally components, it has to be, the architecture has to be converted into hardware and software model, and for which we have to provide the detailed design, what are the components needed, what are the softwares that are required, and what are the simulators that are required. Those are called as components. And finally we need to check the system performance, what is called as system integration. So going to the top down design methodology, it starts, as I said earlier, it starts with top level, and the functional descriptions are here converted into common list on each level, and each function will be decomposed further on next abstraction level only. The layout is given only for the transit component, so not for everything. So Here comes the advantage, that is highest level customization is possible for top down design, and as I said earlier, layout can be only for given for transistor component. So only one transistor library is needed here. So and one layout design at the end will be obtained. So these are all the advantages. And while considering the disadvantages, difficult to calculate the estimation level, metric estimation on upper level, since layout is known only at the end. And then the impact on the design decision is not clear at a higher level, and hotspot removal is also difficult at this stage. The final one is called as bottom up design methodology. Here it starts from bottom level, and each level here generates a library for next higher level. While considering top down method, we'll have only one library for transistor. Here while considering circuit, we'll have standard cells for logic level, and the logic will be RTL component for processor level here. And considering the processor, processing and communication components of the system are here as considered as process. System, embedded system platform for different application will be considered as system. And while designing, we'll have the floor planning and layout on each level. So what are the advantages and disadvantages of bottom designer? The advantages goes like this: abstraction level are clearly separated with its own library, because here not only single, it has many, so it has got its own library. And accurate metric estimation with layout on each level is available here. And globally distributed development is possible, and easy management is also it can be easily manageable. And while going through the disadvantages, an optimum library for each design is difficult to predict, and library customization is outside the design group, and layout will be performed on each level, so it takes too much of time. Thank you.